Okay, let's get started, folks. Welcome to everyone joining in to this discussion live, and those in the future who will see it on demand after this webinar. My name is Jordan Kirakidis, and welcome to this webinar where we will talk about all things LLM. In particular, is it yet another tool? Is it a fad, or is it a game changer that's going to change the way systems engineering and engineering product development is done? We have a great panel here that I'll introduce in a second. I'll maybe a few housekeeping notes first. Please use the chat and the Q&A section of the Zoom application that you're viewing this in to ask questions, or to offer commentary on what you hear, whether you like it or whether you don't like it. And we will attempt to we'll attempt to answer it, or we'll give comments on your comments or on your questions, and we'll have that discussion. The format here is going to be an open discussion where we'll each discuss our own point of views and share thoughts, maybe controversies or things that we don't quite agree on. With us also is Yana J. She'll be acting behind the scenes to making sure everything is run smoothly. She will be monitoring the chat, and she can interact with you on the chat, and she'll also field the questions in the Q&A. Every once in a while, you'll see her pop on, and she'll ask a question at appropriate time during the webinar. And then we will share with some of your comments or some of your questions that we will address as we go along. I think that about covers all the housekeeping here. Welcome to the panelists who joined us. We have three fantastic people here, all with their own point of view, Chris, Nate, and Barclay. We'll start with a brief bio on each of them before we dive into it. First was Chris Elliott. Chris is a member of the Flight Control and Vehicle Management Systems team, and also the Quantum Information Science Research team with Lockheed Martin Skunk Works, and he's based out of Fort Worth, Texas. He's been with the company for 24 years, even though he looks so young. Past roles ranging from the International Space Station, the Block 60 F-16, the F-35 Joint Strike Fighter, the hybrid airship, and a bunch of other research programs. Dr. Elliott is also an adjunct professor at Texas Christian University and at the University of Texas at Arlington, both in the mechanical and aerospace engineering departments. He is also an IAAA associate fellow. He received his PhD in 2016, master's in 2009, both at the aerospace engineering at UT Arlington, also a BS in aerospace engineering in 1998 from the University of Texas at Austin. Thanks and welcome, Chris. Dr. Barclay Brown is also with us. He is the Associate Director for Research and AI at Collins Aerospace, a division of Raytheon Technologies. Prior to joining Collins, Barclay was an engineering fellow at Raytheon Missiles and Defense, focusing on systems engineering methods. And prior to that, he was a global solution executive for the aerospace and defense industry at IBM and worked on the IBM Watson personal assistant systems. Dr. Brown holds a bachelor's degree in electrical engineering, master's degree in psychology and business, that's quite the combo, and a PhD in industrial and systems engineering. He is a certified expert systems engineering professional, ESCP. He's also the chief information officer of INCOSE and also chair of the AI systems working group. His research interests include natural language processing, recommender systems, and philosophy of mind. Thank you and welcome, Barclay. Thank you for joining us. Finally, we have Nate Fisher. Nate is a self-professed aviation geek. He's also a pilot and an embedded software engineer with a focus on civil aerospace applications. His background is in requirements engineering and model-based systems engineering methodologies, and that is what has inspired his participation in this webinar, and we're happy to have him. Nate's most recent contributions involve the design and implementation of autonomous avionics systems at Wisk, and he's based out of California. Actually, the company Wisk is based out of California. I think Nate is based out of Atlanta, and Barclay is also based out of Atlanta. So welcome to all three panelists. A little bit info about myself. I am the co-founder and CEO of QRA Corp, and we are an enterprise software company devoted to the verification of autonomous systems, particularly the verification and validation of requirements, where we can analyze requirements and specify what is concise, what is lack of concision, appropriateness, and correctness where we can. Our products are used by Fortune 500 companies in the energy, medical device, automotive, and aerospace industries. Prior to QRA, I was a professor and head of the quantum theory group at Dalhousie University. I have a PhD, summa cum laude, in theoretical physics from the University of Basel, Switzerland. And I also sit on the Canadian government's advisory panel for AI, advising the government on policies and practices surrounding AI and its public perception generally. And I'm based out of Halifax, Canada. Welcome all. And maybe I'll start by asking the panel, whoever wants to can chime in, on LLMs. We all know about LLMs, unless you've been living under a rock. You've been playing with Wall-E and ChatGPT especially. I'll ask the panel. Oh, before we start, there's one important housekeeping note that all three of our panelists are in the aerospace industry. They all are part of a company, but they are here as individuals. They are not speaking on behalf of the companies. That's an important as a disclaimer. And so their conversations hopefully are unencumbered. But it's important to note that they do not represent the opinions or policies of their companies, right? They are their own individuals in this webinar. Good. Question number one to get us started is maybe share with me some of your thoughts. I'm sure you guys have all played with at least ChatGPT, probably more than you ought to, if you're anything like me. Do you think they're useful for your professional work already today? Right? And if so, how specifically do you think they're useful? Who would like to jump in first? How about you, Nate?
Well,
Sure.
I use it. I use it all the time.
Right.
I mean, so we've got a lot to talk about here, right? So yes, I suspect the panelists have done more than just play with ChatGPT. Would be my guess based on being on this panel. But I find just in terms of day-to-day use, if that's what you're asking about, I do use it for things. I had to write someone in an organization I work with said, can you give me a job description for this person? We need a job description because we're going to hire a so-and-so role, right? And so I said, well, I could write a job description. I know what they look like. They're huge, right? All these things about the company and qualifications, all this stuff, right? No. I go to ChatGPT, GPT-4 version, right? And I give it about maybe 30 words of description about this job. And it does a beautiful job writing this giant job description. And it's the reason I bring that up is it was very easy for me to check and to read the result and to say, yes, this is good. There's no risk in it making up something. See, in that application, we don't have to worry about misinformation or hallucination or anything like that. It just did this job for me and did a great job. I had it write a letter the other day to some things based on some stuff, a letter for a publication, not just a letter to somebody. So yes, I use it for stuff like that.
Yeah, I'll second what Barclay says. I mean, I think obviously it's valuable out of the box. Main issues that I've seen with it in my day-to-day, one, are that it tends to spin you in a direction and and I'm talking about the 3.5 turbo model, ChatGPT, doesn't necessarily arrive consistently at a solid answer. So we've had to fine tune it to really get it to stop. Like, okay, your input, this is good enough, and this is where you stop. Otherwise, you just kind of keep spinning forever. And two, of course, is the IP issue. Public, AI as a service models are okay, I guess, as toys, or maybe or for less complex programs, or maybe with programs without IP barriers. But really, I think the challenge is finding value in open source models that can be hosted in virtual private clouds or on-prem. And that's where a lot of, I think, the work goes on my side, is creating enough fine tune, creating enough training data essentially to get those open source models to a point where they're valuable. And I think at this point we can, because those open source models are huge and super valuable.
If you try, oh,
And
go ahead, Chris.
I'll weigh in here and I'll say thank you, Jordan, Dr. Kirakitis, first for inviting me to this panel. I'm humbled by the background here and looking forward to learning from the speakers. I'll start off, I'll say I'm not an LLM expert, right? I'm a flight controls engineer within aeronautics, but we do have a very good trust or team of people that have stood up a Lockheed Martin Artificial Intelligence Center. My colleague Justin Taylor leads that effort. And I witnessed a talk just recently on the excitement behind the LLM and a lot of the things that we're looking into as a company to improve we do business, such as what Dr. Brown mentioned, just a basic search. How can I find files across programs and just a smarter Google search within the company for improved efficiency. For the flight controls domain, I'm interested in reducing the operator's workload. And I see a very good bridge there between LLM and how the operators interact with our assets. I have explored it briefly, just kind of playing with some of the engines. I think it's an exciting technology. I don't think it's quite ready for prime time based on my limited view of it. For example, I had it program a functional tic-tac-toe game in the MATLAB syntax just a few weeks ago, and I was very impressed at how far it made it, but it didn't quite establish all the rules completely correctly. I've seen some students abuse it in the past by completely relying on this technology to provide cover letters and queries for positions within the company. So we need to check that and make sure our students are aware of the fundamentals before relying on that. I'll just briefly say though that I'm excited about it. I think it's going to help us shatter the silos. We're always trying to get our different domains of expertise to work together. And that LLM, I think, is going to be an enabler for that and really the backbone for this whole digital thread and digital transformation buzzword that we've all been hearing about recently.
Yeah, that's really interesting. I would say from my own experience, it's also, I've used it from things like you mentioned, Barkley, things that aren't, I would say, in my core day-to-day work, especially on the technical side, but really all the things that kind of surround the work, like job descriptions or things of that nature. What strikes me, which is both, to my mind, impressive and also, I'd say, a little dangerous, maybe even a little bit spooky, is how well some of these LLMs actually write. Like the quality of the writing is really top notch, and it gives me a false sense of certainty that it must be correct. Look how well it expressed itself, and that can be a little bit tricky. Nate, you seem like you had experience with a whole host of models, including some that you download and play with. I would say most of my experience is on the chat interface with OpenAI's various models. But have you also seen that as well?
Yeah, absolutely. I mean, I think all of them, have a whole bunch of in-domain information that may be accidentally valuable, but it could just as well be accidentally detrimental. So in my view, any of these things are good for mainly one thing, and that's language transformation. They're not good reasoners. They're not good encyclopedias. They're not good mathematicians. So if you're using it for that role, then really your job is to perform that transformation and then ground the answer in such a way that it's valuable. So for example, let's just talk about requirements analysis for a second. Yes, it's going to be great at transforming natural language into something that's more structured. So then you could use something like Spacey or procedural NLP to maybe make use of that. But to do that, I think you also need to ground it in such a way that it's easily verifiable. So for requirements analysis, for example, I would say it's not just give me a better requirement. It's tell me what's wrong with it, why, and give me a better requirement. And if you can train it with enough data to give you that answer, like say using the NCOSI spec, the 40 rules and the NCOSI guideline of writing requirements, if you give it enough training data, you can consistently get that, and it starts to become, in my opinion, that's when it's really valuable. If you're just saying, give me a better requirement, it'll give you something, right? But how valuable that is, I would say is questionable.
So it sounds like you're saying this analysis requires verification or requires justification of, why it gave the answers it gave.
Some grounding, yeah. And that's true, I think, for all models. I think the core technology is language transformation, not being an encyclopedia, not being a reasoner, not being correct.
So can you maybe explain a bit more for us if you can explain more precisely what you mean by language transformation, right? Like, do you have any examples that you can give on that?
Yeah, exactly. So let's just say you want to, I don't know, put stuff in ears, right? And so I've got, a really wild statement that says something like, the red light needs to turn on when you push the button. And actually, I would like you to transform that statement so that it's an active voice. It has an actor. It has triggers on the front. It has responses on the back. Maybe it uses some symbols that I've preloaded with it. Like, it's not the button. It's like command underscore button underscore activate or something like that. And that transformation of the input to that structured format is, that's what these things are really good at. And they're particularly hard with procedural NLP because there's just so many variables, but as a front end to procedural NLP, it's amazing. Asking it, who the 23rd president was, that's kind of a useless, that's kind of a gimmick, in my opinion. I think what would be way more valuable is saying, oh, the user's asking for something about a president. It happens to be in order. Therefore, I can go look up in this database a whole bunch more, a dense vector of more information, and bring that into context and do something with it. Like, that's valuable. Grounding it is valuable. Using it as an encyclopedia within domain knowledge, I think is not quite as valuable.
That's surprising to me. As I sometimes like to say, GPT-2, nobody's ever heard of it. Why has nobody ever heard of GPT-2? Well, because it didn't make a big splash. It's a model that's about on a scale with many of the open source models. In fact, I think OpenAI has open sourced GPT-2, in fact, right? And there's a bunch of others of that sort of scale that have been open sourced. And naturally, people in corporations like mine and yours and all of ours, right, gravitate toward the open source models because we can get them, we can bring them into our own environment, run them privately, run them even in a class environment, perhaps, right? And privately, right? But why did GPT-3 make such a splash in the public consciousness and even in the AI world? Is that there was in my view at least, a dramatic increase in capability. And the dramatic increase in capabilities in two dimensions. I think this may get to what you were saying, Nate, too. I think when we think of large language models, I like to think of them as having two primary skill sets. One is the understanding of language, and the other is the knowledge actually contained in the model. And in human beings, we've never had to think of those two things separately that much with human beings, right? Because when we grow up, we learn language and we gain knowledge kind of together. They just kind of grow together, right? Can you imagine somebody who is completely expert at speaking in English, but knows nothing, right? Has no information. It's hard to imagine, like what would that even mean, right? So, but that's what you have kind of with a large language model. So the interesting exploration is, all right, you have the big public models, GPT-3, GPT-4, which by the way, top the open source models in benchmarks on knowledge and reasoning by a 2-to-1 margin. I mean, it's not even close. And I think that'll change. I think that's just today's situation. I think my guess is, but before long, we will have a GPT-3 level model that's open source that we can download and use in our companies. And then OpenAI will be touting the latest GPT-7 out here that does some new thing, right? And there's this the whole thing is going to move. So it won't be long before we have open source models that can do what even a GPT-4 today can do, probably.
Yeah, I think that's really interesting. That's a good articulation of something I was trying to say earlier, that it's kind of spooky how well GPT-4s can but type. The language, the quality of the written word is actually quite good, even though if something saying is sometimes sometimes obviously incorrect, right?
What's even more shocking, and you guys probably know this, I don't know if everybody does listening though, is how it works. Because it literally, what it's doing, to put it really simply, you may have heard this, it's predicting the next word in the sequence, right? So what you gave it, it says, okay, I got what you gave it. Now, given everything I know about English language from everywhere, what's the next most likely word? And it gives it to you. And then it says, all right, given your prompt and that word that I just did, that whole thing, now given all that, with all my knowledge, what's the next most likely word? And that's literally what it's doing. And yet it can write limericks, and it can write poems in Dr. Seuss style about Elon Musk, and it can do all this stuff. So it made me wonder, oh my gosh, what is going on in here? Is this mostly what we're doing is playing with language in our heads? We're remixing language. And what I think, this gets to something practical here, believe it or not, is that there are parts of our jobs, of all of our work, that probably are just rearranging language. And so it makes me think, wow, could those be done by a large language model? Maybe not today, but at some point, right? And leaving us to do the more creative stuff that I think large language models will never be capable of, just because, and my argument is not from time, it's from the design. Based on how they work, they cannot be creative in the human inventive creative kind of sense. They can give the appearance of it, but there's still a gap between what human brains do and what large language models will ever be able to do, in my opinion. Speaking only for myself, like Jordan said, not for Collins or anything.
So never is a long time.
That's right. I'm going on record with never.
That's right. Yeah.
And again, I speak sort of as a philosopher, among other things, right? So there's some philosophical arguments behind that, not just a timing thing.
So the point where you said that it's an interesting point of what they do, let's call it microscopically, of predicting the next word. Actually, the next token is what they predict. So even like
that's right.
Subword.
That's right.
It is, and yet this amazing thing gets produced. It reminds me of, my background is in theoretical physics, and it reminds me of sometimes the stuff that we see in physics. If you ask the question, what is consciousness, right? And as long as you subscribe to question now, as long as you subscribe to the notion, that it is something that just lives in the brain, then we know what it is. It's electrons and ions interacting with the electromagnetic force, and that's all there is. There's nothing there. It's only when you arrange them in a certain way, you get this behavior coming on. So when you reduce it to the fundamental forces, everything is very simple, but the complexity that arises, the organization that arises, can be infinitely complex from something very simple.
It's called emergent behavior in the past.
Right. I was going to say, yeah, Chris, you were right on there. That's emergent behavior.
Emergent
that's right.
Behavior, completing each other's sentences, and going back to what Nate said to begin with, the idea of this as a language transformer, to allow all of us to hear it in a certain context so that we all interpret the design in a more efficient manner. To me, that is really the spirit of what you're saying. That's a phenomenal comment. We have issues all the time with folks interpreting the intent of the design, right? And QRA, I'm not going to go into a commercial here, but QRA has been working on that very problem. How can I better interpret the intent of the design? That's phenomenal. So, it's not necessarily, I see it as providing a means to the dictionary, to the different domains of expertise. If I can explain it in your domain of expertise, then the engineers can quickly interpret what your intent is and make a more efficient design. So my example that I'll leave you with is, we actually have a public domain challenge problem that Jordan's worked in the past, and it was a system that managed a terrain following exercise. So the airplane is terrain following, and it's a federated architecture that's listening to sensors and a flight control box. If the sensor says I'm invalid, I don't have data, I can't see the ground, the job of the flight control system is to fly up and get away from the terrain. Well, it's kind of a closed loop. So it's invalid on the sensor if the system's flying up, and the flight controls would say I'm flying up if the sensor's invalid. So both these two different domains are listening to each other, and you end up getting into this limited cycle oscillation in a very real flight control example that we studied in the past. That's a prime example of not understanding the intent of the requirements, and perhaps the large language model is really the enabler to improve that. just wanted to share that example with you.
I love that example, and it, to me, it points to maybe a different value, that why I'm so excited about large language models. Okay, part of this is my background in psychology, philosophy, and all that kind of. It's like a follow-on to that. It's the Chinese room, right? It's a zombie, right? To use some philosophical terms, right? But anyway, the interesting thing about it is, we humans have never found a better way to communicate with each other than talking and writing words, language. Isn't that kind of odd that we haven't? With all our advances, we still talk to each other. And I promise, Chris and Nate, in your companies, right? If you're going to communicate to me a design of something, if I'm from DARPA or the government or whatever, and I'm saying, give me a briefing on this design. Yeah, you're going to show me a few diagrams and a few pictures, but mostly you're going to talk to me. Yeah, and you're going to summarize and you're going to generalize. And you're going to say this and this, and I'm going to ask a question. You're going to give me an answer, and the answer is going to be more language, right? So we communicate about all this, and large language models being good at that is really interesting. So I love the application you're talking about, being able to rephrase and re-express the design of a system. And even have you ever tried to ask GPT-4 or something to say, rewrite this for a 10-year-old to read? And it's very interesting, because it's happy to do that, right? I asked it to write something like a 3-year-old the other day, and it put in all the little mispronunciations that 3-year-olds make and stuff like that. It was hilarious. But to translate something into it is kind of a translation, like reforming into something. Because to me, the essence of requirements is not. And I'm happy to hear about the new experiments that you mentioned QRA was doing, because getting requirements in a better format may not be the path to improving systems development, right? It's more understanding the system and seeing where there are holes or contradictions or problems in our understanding, or in some other group's understanding. Maybe we understand it, but those guys designing the avionics don't understand it, and that's a problem, and trying to bring that together, which we use language for. So I don't know, I'm hopeful about this kind of stuff.
Yeah, that's really interesting. In fact, I'm thinking more and more, I'm thinking of the purpose of requirements at all level is really to communicate a shared understanding of where the system is today.
Right.
So in that sense, requirements cannot be one and done, because it means that your understanding of the system doesn't change. And in fact, it's always changing. So as the project proceeds and you get closer and closer, the understanding changes, the shared understanding changes, you learn things. And so that should be reflected somehow in the requirements. I agree with that very much. That was well said. Another interesting point about the pervasiveness and efficacy of language, I think, is also very important. It still is the best medium we have for communication. I'm even at the point at my company, I haven't quite had the courage to do it yet, but I'm pretty close to banning the use of PowerPoints and say, I don't want a PowerPoint. I want you to write a narrative of what you actually want to say, because when you write something down, you can't hide. If there's a gap in your knowledge, it's immediately shown, even as you write it just for yourself, right? And so,
that's really interesting. I might steal that idea, because if you force people to write, extending on what you're saying, if you force people to write complete sentences as opposed to just bullets, it drives a different kind of thinking, perhaps a more complete thinking. Certainly
does. Yeah, I know it does for me as well. So I try to write as much as possible, although I wouldn't burden the world with it, but it helps us. It does help with thinking.
Interesting.
Hey, Jordan, I'd love to tack on one more thought to the language transformation thing.
Yeah.
So, Barclay, you were getting at, language as kind of universal truth, the universal, medium. And yes, but also there's lots of different ones, right? And I think, what you're getting at with intent really is like the core promise of the whole MBSE craze. Like, it's not just requirements, it's the system model that, is totally connected and knows everything about the system that I'm building. And if you were to change over here, it changes over here and all that kind of stuff. And that's all great, right? Great idea, except only the anointed ones have a license to the tool, know the language, know how you represent it in the language. So even if you know the language, I could teach you SysML, right? I could teach you that this box connects to this box with this symbol and all that kind of stuff. It doesn't mean that you can go write War and Peace, right? Or some fantastic work of literature. Just like, even if you know SysML, it doesn't mean that you can get in there and go build some, really well architected thing that's going to transfer knowledge to other people and other stakeholders. But that is a transformation problem. And if you can somehow represent the linked list structure, the graph structure, or whatever it is that you've happened to use to represent that system data structure wise at the core. And if you can represent that in intermediate forms and transform it, that's what these things are really good at. So imagine, instead of saying, hey, Barkley, can you tell me, does the mission computer talk to the navigation lights, and have Barkley go open up Cameo or Enterprise Architect, find the right model, make the query, figure that out. If you could just throw that into an LLM and say, you know what, pull in the right context, figure it out, and just give me an answer. Well, now I've just basically just realized the value of MBSE, right? Now you can go to your chief engineer and be like, hey man, go, or woman, ask anything you want to this model, and you get an answer, right? I think that was the promise, and it hasn't been delivered, but there is an ability, I think, for this kind of tool to deliver that, because that's a language transformation problem.
Another excellent example, Nate, you're inspiring me with your thoughts here. So, the traditional process is write down the requirements, okay? Now decompose the requirements and everyone go off and implement, and we're always checking to see if we meet those requirements. It doesn't always work that way, and it often does not. What actually happens is the engineers listen to you, as Dr. Brown mentioned, they understand the intent, and they go off and they implement. And then they come up for error later and they say, well, what do we build? I better write that down as requirements. And that's broken, that's right? That's where you end up not meeting at the same point. So it's could you write down the idea, translate it into the domains via an LLM, implement it, and as you're implementing, you're continuously inverting that transformation with the LLM back to the other domains to always converse that idea, sort of like what we're doing here over Zoom with just natural language, always conversing, to the other domains on what I'm actually implementing. It's really exciting, and we'll see where it goes from here.
It is. Here's a perhaps an analogy for that kind of activity. Imagine you have Walt. Do you know Walt? Walt is this old guy or woman, doesn't have to be male, who knows everything, right, in your company about your domain, right, who knows all about building this kind of systems you built. She's been around for a long time, knows everything, and is completely up to date, reads like crazy, understands everything about the current projects up to the minute right now, because he's like looking at everything and running around and all that. And you have a copy of Walt, a Walt clone, sitting right next to you all the time. And Walt is not a limited resource. You can talk to Walt as much as you want, as often as you want, and everybody has a Walt, and all the Walts share a brain, right? So they're all informed all the time. Mm-hmm. Would I then need, this is a kind of a challenging question, perhaps intended to be provocative a bit, Nate, right? Would I even need a SysML model? If I can just ask Walt a question about the system and he can answer, why do I need a SysML model? Why do I need requirements? I can ask Walt. Walt's right there. He's ready. It's cooperative.
That's actually a question that we've asked internally here at QRA. One of the early ideas we had is, can we build a tool that generates a SysML from text, right? In principle, I think it's doable. Right? If your text is sufficiently detailed, you ought to be able to generate a SysML diagram from it. Or if not, you also ought to be able to use an LLM to tell you what you're missing in order for it to create a SysML diagram. But this whole thrust, let's call it, or trend towards model-based systems engineering, on the face of it, seems like an obviously good idea. The only hesitation I have is that it's been an obviously good idea for a very long time, and people still haven't really adopted. SysML is not new, right? MATLAB or Simulink is not new, but why have so few people, so few companies actually adopted it? Is insofar as the question is, and I know Nate, you are into MBC, so maybe I'll chime in on here. Is it the case? So if it is the case that the reason it hasn't been done is because the tools just aren't there, it's too difficult to use, and so no one bothered doing it. Is that the case? And if it is the case, can we just get an LLM to generate it? And do we actually need, if we, like you said, if we have Walt, which is a great name for a future product, so you'll steal my idea if I steal yours.
You're gonna go build Walt? Is that the new goal?
Yeah. It's not imminent. that's a good point. Maybe I'll pose it to the rest of you. Do we need SysML if we have someone like Walt or an LLM system that can actually look at the requirements, look at the text, look at the code, even CAD drawings, and be able to answer these questions and communicate with people? Right?
It's quite possible. I mean, I'll tag on to your first question about MBSE. I've worked in MBSE for decades, kind of since the beginning. That was my main thing before I became Mr. AI, was Mr. MBSE, right? And it's you're right. I think the language is too hard, and it was too big a leap. So we leapt from plain language requirement statements mostly, right, to this fairly arcane a diagrammatic language, right, of SysML. Now, SysML version 2 is trying to walk that back, by the way. If you look at it, SysML 2 is conceptually simpler, but it's a huge change. So that's another big problem, right, is now people have to relearn SysML 2. SysML 2, by the way, as you may know, has a native text format, a native text expression. So SysML 1.x never had this, right? So SysML is actually, you talk about SysML being a text language, it actually is a text language, right? And as well as having diagrammatic and graphical expression. So maybe, the thing I would tag on to Jordan's question is, what do we use those SysML models for? Well, they're mostly to communicate to people. They're descriptive models. So we create the model so that people can look at it and get answers to their questions that they form in their mind about the thing. But maybe we can just put the question to Walt and we don't need the diagram. So that's where I think you were going. Let's see what the other guys think.
Yeah, and I love the idea of Walt. As long as we don't call it Hal, I think it'll be fine. So 2001 reference. But real quick, I'll mention my colleague Mike Scaff, F-35 pilot, and he's working to bring Walt on the airplane with him. So as an instructor, he's very empathetic, right? So he's monitoring his students and he's understanding when they're under high workload and when he needs to intervene. How do you automate that? That's phenomenal and really just the future from my perspective. But what I'd say is, you mentioned the need for requirements. Going back to Dr. Kirakidis, his question, do we need requirements with an LLM? Does this basically supersede the idea of writing something down? And I think it does. I mean, if you think about requirements, I can write it in Microsoft Word, I can put it in a PDF file, I can put it in Doors, Excel, Jira, you name it, all these different tools. And the whole idea is I'm trying to synchronize something for the entire team to reference, something that's under configuration control, configuration management. If the LLM can do that and it's synchronized across the team, I'm fine with that as long as it's deterministic and repeatable for the same inputs. It can't be stochastic or subject to interpretation. But anyhow, let me turn it over to you.
I would say, so in my view, well, first of all, LLMs are not deterministic. They are probabilistic and statistical models. And in fact, you get some of the best results when you turn up the temperature a little bit to get a little noise. It is actually makes them even better to do that. So you kind of want that determinism, particularly for the generative part, right? And I'll go back to something Nate said at the top of our discussion, that it seems to be these models are good for the generative part, coming up with ideas that you didn't have before. So there's two use cases that we're talking about here. One is, if you have a Walt who remembers everything, knows everything, then you could just ask Walt, and it can basically has the information available to you, and they can tell you that. Then the smart part, or the AI part, there is to figure out of all this plethora of information I could give you, which is the one you actually, what's the question you're actually asking? I have in my mind a future tool. If you ask it a question, it'll say, here's the answer to your question, but here's the question you should have asked, and here's the answer to that question, right? That's what you should be paying attention to, right? But then there's also the creative aspect of something that creates something that did not exist before, something that is new, that brings into it. And to my mind, that is kind of the exciting part. And it is part of transformation. Transformation is, you transform into something that did not exist before, right? You're creating something that is new. So I'm not sure I would quite call it creating new knowledge, but it is something that is new, that did not exist before.
Yeah, what's truly new and what's creative is a tricky tricky thing.
It
But you
is,
touched on
yeah.
something that I think is really interesting about where do we see LLMs going? I'm sure that was a question you were going to put to us at some point, but I just want to throw in a possible answer here.
Thanks. I see your time is actually almost done. So thank you for that. It is very
Oh,
important.
okay. All right. So I better get it in quick. All right.
Yes.
So I'm intrigued by somebody, and I don't know if it was Sam Altman or one of his people at OpenAI, who said that what they see in the future is that LLMs will be able to do anything that we currently do on computers.
Mm-hmm.
And my response to that is, holy crap, are you kidding? I mean, right now, LLMs cannot do anything like everything we do on computers. They can do some things, right? But if you imagine Walt V2, or maybe it's Walt V7, right? Who you can say, set me up a model in MATLAB to simulate the something versus the something with these parameters and run that and get the graph, and then take the graph and put it into a PowerPoint and then add some more text explaining this. You know, I give it a bunch of instructions, just like I would give to like an intern or something. And Walt can carry that all out because it's connected to all those things on my computer. That's future, right? That's where things are going to get really interesting.
On that note, let me fast forward the clock a bit. Fast forward it, let me say 5 years, maybe even 10 years. I'm not sure how long, but some kind of in the past, far enough that the probability of you being correct goes down to zero, right? That far ahead. And you all work in aerospace. You all do engineerings at different levels. So you see and you understand the day-to-day work to do your jobs at, let's say, down at the ground level. And you use a bunch of tools. You do lots of talking to people, and now let's assume that LLMs keep improving. How do you think that what will your workplace look like in the future if LLMs are now pervasive, right? And I don't mean just the initial chat or conversational interface that we've mainly been talking about now. Will there be other interfaces, and how will it be insinuated? And how do you think the workplace will be different in the future? A bit of a loaded question, I'd say.
Try and be brief here. I don't think you'll know really that it's an LLM. I mean, just like you don't know AIs and a lot of the tools you have today. It's not about getting a bigger model. I think it's about trying to solve a problem. So, for example, I don't know, like requirements transformation, for example, you don't need a 170 billion parameter GPT 3.5 model. I mean, we do it really well with a 7 billion parameter Falcon model that can run on your laptop, honestly. So, I think it's really going to be about solving problems. Specific problems, not just creating a language model and making it write haikus or something fancy like that.
Well, my image that I'll throw out is, and I often make the point, I don't know if anybody's a huge Star Trek fan, right? But did you notice that the computer on Picard's Enterprise was far inferior to the computer on Kirk's Enterprise? And this was because of the level of hope that there was about the capability of computers in the 60s when Kirk's show was done, and in the 80s when Picard's show was done. However, what I'll say is the future of LLMs may bring us closer to what was on Kirk's ship. And if you remember, on Kirk's ship, they interacted with the computer through talking. They also had buttons and switches and all this other stuff. And it was a combination. It was seamlessly integrated. They could push buttons. They could talk to the computer. They could ask the computer to do something with the ship, or they could push the buttons. And it was this seamless interface. And the computer also had access to all information that they had and could correlate hypotheses and do some stuff that until LLMs looked crazy, right, to us now. But that's what I see is it becoming integrated into every facet, where we'll have verbal assistants, partners. I don't want to call them beings, right? Because they're not going to be conscious, right? By, I think, the best definitions, but they'll be able to act like they're conscious and talk like they're conscious. That's what philosophers call a zombie, right? It acts like it's conscious, but it's not. But that's fine. For Walt, I don't want him to be conscious. I want him to do a good job for me,
So my only regret with this panel session is we don't have a nice cold beer to share, but I think this conversation should continue at a local pub. And I'm definitely a Star Trek, Star Wars fan. But real quick, just in 5 years, for Jordan's question, I often write a utility or run into an error, right? Why is my code not compiling, not linking? We go to the search engines. You find that what is it, the Stack Overflow
Stack
forums.
Overflow, man.
You scroll down to the first reply. I look for the first reply that has the green check mark. That's the one that's accepted by the community. And now I'm going to look at that solution. The LLM is going to completely change the way the engineer does business. So we're not redesigning utilities. We're not running into those problems and troubleshooting. So to me, that's really exciting. And then beyond the 5 years, that's where we start to talk about autonomy and real-time systems. Like I mentioned before with the operators and how that AI is going to improve our real-time assets. But just real quick, I think in 5 years, it's going to change the way the workforce operates. And I'm already seeing that with the students that are coming into industry today of why are you not using ChatGPT for these basic cumbersome tasks of writing down in English your cover letter.
There is one comment I will that came from Irfan in the chat that I think is a good one to maybe end on. We've all been generally pretty, with the panelists, pretty pro LLMs, right? We always say this is happening, it's going to be good. But there is a saying that a fool with a tool is a dangerous fool, right? And so if it's true that LLM, we already see them creeping into the workplace, and a lot of companies are having to quickly play catch up and try to, you know, to your point earlier, Barclay, I think you mentioned too, Nate, about security and privacy and something being local better than being online. And that's because companies have to quickly make policies on how they use GPT, because the engineers, not just the engineers, everyone is actually using it already, right? So the cat's out of the bag in some sense. So as it starts influencing and insinuating itself deeper and deeper into the everyday work, do we need to establish some kind of like safety protocols or certification, or is it going to be just like, you know, everyone can use it? And because if it has that much power, it's also pretty dangerous as well, right?
Well, it's knowledge, and this is emerging. And I'll throw out one concrete recommendation. If you consider yourself a fool with ChatGPT, here's how to get out of being a fool. Go to deeplearning.ai. This is, I have no financial connection with them or anything. I just think it's the best online training in AI going. And they just launched a few small free courses. One of my favorites so far is prompt engineering for developers. So this is about how to use these large language models, how to prompt them the right way, how to use them in applications, not just prompt them interactively, but prompt them from your software through API, right? And how to design applications and stuff like this. So this helps. But I think the answer to Irfan's question is yes. People do need some training to get the most and get the correct and best results out of these things. It's not just about sitting down and chatting. Okay.
We have run out of time. We've gone a few minutes over, and we've just barely scratched the surface. So maybe this ought to be a series of webinars instead of just one webinar. One thing we didn't even scratch the surface on is, what about the regulatory industry? How do you approve these systems that are LLM has a big say in doing? How do you verify these systems other than getting the LLMs to do it? We want to, obviously, that's a huge topic that we cannot touch. I would maybe end off with a few closing comments that anyone has, or any points that they wanted to make that they haven't made. Last opportunity to do this before we close it down for the day.
I'll just close with a couple comments just to squeeze in an answer to Irfan's question. That, you know, I think there's an approach there similar to what we do in safety critical systems, right? So to make me resilient to a failure, I need a set of independent channels, and I'm comparing those channels. I'm comparing the answers. So in that case, I have multiple fools I'm listening to, and I'm trying to come up with a composite score of who to trust. Is there consensus? Is there dissonance across those fools using those tools? And we're gonna have to come up with something like that, a voting scheme to listen to an ensemble of LLMs, I think, you know, to get past this. And then the last comment I'll close with is something Jordan mentioned earlier, the idea of a stochastic LLM. I'm fine with exploration, but in order for this to supersede requirements and it becomes deterministic, it has to converge to that exploitation rather than exploration. So just a quick follow-up on that. But I've enjoyed meeting with all of you, and I'm convinced that we're in good hands going forward the next 5 years. Please reach out if I can help you or have a beer with you. That'd be fun.
Yeah, Jordan, thanks, Yana, Jordan, and Barclay and Chris for having the chat. I think this is a huge, interesting topic, and yeah, good to meet everybody. Thanks.
Nothing else for me. I excited about this area. I think we're just barely seeing the beginning. That's what's so fun about it.
Yeah, I would thank you all. I would leave with one comment that from physics and background. When the lasers got created, they call it light, which is what it is. But we don't use lasers for ambient light or light bulbs, right? We use them for everything except what we use all other sources of light for. And so that's an example of how divergent the applications of LLM can be, that we have no way of thinking. Who would have thought with lasers we'd get supermarket scanners, right? That is all the time we have for. Thank you, people that are listening now, and thank you for those that are seeing it on demand. I apologize we didn't get to all the questions that were asked, but the conversation just kept on going, and it was a fast 45 minutes. Hope you all have a nice day, and we'll see you all soon. Take care, everybody. Bye-bye.